Homework can be one of the most powerful things to help you learn. But it's got to be reviewed and thought about, and if all you do is, well, write down correct answers, erasing your work, then it won't really help. So I'd like to go over this first homework assignment with you, show you what I was thinking and how I would answer these. And what I would suggest is that if you did these problems, don't erase them if you got something different. Just write down, maybe in pen or something, things you learned. So let's get started. So the first one says, change the following to a rational number. Well, this is already a rational number, so there's nothing that needs to be changed. But if you wanted, you could do 5 over 1, that's rational. You could do 25 over 5. In fact, you could do any fraction that reduces to just 5. So any number, a divided by b, that would equal just 5. So this isn't an answer. It's just an explanation. If you had a number divided by another and the answer would reduce to 5, then that would be an appropriate solution. Now this one right here, 0 is also already rational, just like this, but we could do this right here. You could do 0 over any number you want except for 0. And then it would still be rational. And again, the reason that is because this expression right here, 0 divided by 5, it's really saying 5 times what number equals 0. So 5 times 0 equals 0. So anything divided, or 0 divided by any number except for itself would equal 0. So that would be appropriate. Now this one's a little trickier. This is 3 divided by 4/10. So this is really 3 divided by 4/10. Now 4/10 is reducible to 2/5. So what we really have is 3 divided by 2/5. Now the way you divide, it's like this right here, 3 divided by 2/5. Now the way you divide is you multiply by the reciprocal. So this would be 3 times 5 over 2, which is 15/2. Okay, now this one's got a little bit more of a procedure. I don't know if you remember this or not, but in this lesson what we talked about was how to change a repeating decimal into a rational number. So we don't know what the answer is, but x will be the number that is written like this when it's converted into a decimal. So x is 0.23 repeating. So it repeats after the hundredths place. So what we're going to do is we're going to multiply both by 100, both sides of that by 100. We're going to get 100 times x equals 23.23 repeating. And then we're going to subtract this one from this one. So I'm going to go ahead and write it like this. We're kind of running out of room, but 100 minus 1 is famously known as 99, and 23.23 repeating, those things repeat the same exact way, so what you're left with is 23. Divide both sides by 99 on the fraction, whose decimal approximation is 0.23 repeating, is right here, 23 over 99. There we go. Now, why is the following undefined? The reason this is undefined is because this is saying 0 times what number equals this number. Well, 0 times anything is always 0, and you can't divide by 0, so that's why this is undefined. There's no number times 0 that will equal anything except for 0, and you can't cut something up into 0 parts, so that's why this is undefined. You can't divide by 0. Like for example, if we did 0 over 5, this is saying 0 times what number equals 5. There is nothing times 0 that equals 5. It's undefined. Undefined means it's not a number. There's no number. Okay, list all of the sets of the numbers that these belong to. So this one right here, this is real, it's rational, it's a whole number. Oh, and I skipped. It's an integer as well. It's good not to skip the sets, because then you'll miss one on accident. This one right here is all of those and whole. That's what this one is. This one is, this one is real, rational, and an integer. But it's not a whole number because it's negative, and it's not a natural number because it's also negative. All right. Now, I know my handwriting is kind of sloppy, but I did type this up in a PDF, and I will post a link in the shows in the video's descriptions. Now this one right here, it's a repeating decimal. That means, well, it's real and it's rational. But it's not an integer, because integers are the opposites of the whole numbers. This one is real, but it's irrational. Pi is irrational, and a rational number is the ratio of two integers. Pi is not an integer. This one is the same as that one. It's a repeating, or it's a non-repeating, non-terminating decimal. So it's real, and it's irrational. Okay, can a rational number also be a whole number? Well, yes, of course, because all whole numbers are also rational. So all whole numbers are also rational, but not all rational numbers are whole. So like, for example, 1/2 is rational, but it's not whole. However, 5 is a whole number that's rational. So yes, and I guess I might want to justify it in words. The reason that, yes, a rational number can be a whole number is because all wholes are rational. All right. What number is whole but not natural? 0 is not a natural number, but it is a whole number. In fact, yeah, it's the only one. All right. Almost done. Okay. How many seconds is 0.48 of an hour? Well, before I would like to answer how many seconds this is of an hour, I would probably try to figure out how many minutes this is of an hour. And all you would have to do is multiply 0.48 times 60. Well, I got my fancy calculator right here. I could probably figure that out without one. Oh, look at that. 28.8. 28.8. That's how many minutes that 0.48 is of an hour. So there's 60 seconds in each one of those minutes, so that gives me 1728, 1,728 seconds. Now let's see, I want to make sure that's right, okay? So I happen to remember there are 3,600 seconds in an hour, right? So what I'm going to do is I'm going to divide 1728 divided by 3,600. 0.048. So what I did on paper here is I took that many seconds and I divided it by how many seconds are in an hour, and I just did the calculation and I got 0.48, and this is being divided, so you'd multiply by the reciprocal and it would be 0.48 of an hour. Anyway, quarter of a foot. 0.25 is 1/4. There are 12 inches in 1 foot. That reduces to 3 inches. Onward and upward. Give 2 examples of how the commutative property does not work for subtraction. So check this out. 5 minus 2 is not equal to 2 minus 5. You change the order, but you don't change the sign with it, then it doesn't work. You could do 8. You could do negative 8 minus 11 does not equal negative 11 minus 8. This is negative 19. That's negative 19. Oh my goodness gracious. Well, that's a sad story. Here's why we got mixed up. You see that right there? And this does equal, because they're both negative. Well, that was not on purpose. That was on accident. So let's see if we can get this right then. Let's see. 7 minus 2 doesn't equal 2 minus 7. That's an example of commutative property not working. Okay, that gets a little tricky though, because, well, subtraction is addition of the opposite. So what we're really doing is we're adding 2 negative numbers here. And you can change the order of addition. Well, that is fancy. All right. Now, there's a lot of ways you can answer this one right here. 3 minus 4 plus 7 times 5 times 2. So many ways you can answer this question that are correct. So you need to add parentheses so that it doesn't change the value. Man, you could put parentheses like that if you wanted. You could put parentheses like this if you wanted. Because when you look at PEMDAS, when you look at the order of operations, we've got 3 operations going on here. We got multiplication, addition, and subtraction. Now you can change the order in which you add You can change the order in which you multiply. You can't change the order in which you subtract. So as long as you don't do anything like this, you're okay. Also, you couldn't like group these two things together either. So as long as you don't take this addition or subtraction and you move it up into a group so that it happens before the multiplication, you're good to go. So anyway, hope this was helpful. If it was, you can just click like, maybe subscribe to my channel. You've probably already been to my website if you did these. If you have any questions about anything we haven't gotten to yet, you could always ask me on Twitter. Here it is, Bearded Math Man. That's where I am on Twitter. So hit me up with any questions you might have. Anyway, thanks for watching.